Morning. Today we are going to talk about one type of data structure, which is a linear data structure, and it is linked list. A linked list is actually it is a type of data structure which you will connect all the data together. Okay, we'll start up with this. Okay, introduction to single linked list. Okay, it is a type of data structure. To be specific, it is a linear data structure, and it is a list. You're going to use a type which is called as a list or an ordered list. Okay, and this in this you're going to have you'll be having a one particular thing, one particular element which is called as a node. In this node you'll be having a separate part for data and a separate part for its address. One part is for data, the other part is for the address, which is going to point to the next node which is connected with it. Okay, so this is the concept here. You can assume this is a compartment of a train. One compartment will be connected to the other compartment. Similarly, you'll be having data and you'll be having the address which is pointing to the next node. Okay, the concept node comes here. Okay, definition of single linked list. In a single linked list, in general, you'll be having a node. It is a node. A node is a collection of data. You'll be having data 1, data 2, up to data n, and you'll be having links or pointers. Link 1, link 2, link 3, up to link m. Each item in a node is actually, I've depicted in the diagram here. Each item in a node is called a field. You'll be having two fields here. One is a data and the other one is a link or a pointer. As I've depicted here, the starting will be the header, the address, the pointer will be there, and you'll be having one particular node that will be bifurcated into two. One is data, the other one is the address. The address will be pointing to the next node, and it goes on like that. And the final one will be having the last node will not be having the corresponding address, will be given by zero or null termination, so that it is ending there. Okay, that is null. Okay, you're going for the next slide here. Okay, how to make insertions and deletions. Actually, before your linked list, you'll be learning. You might be well versed with arrays. In arrays, it is difficult to add in between or delete in between. So to make the arbitrary insertion and deletions more convenient, you're going for linked list. Okay, here you're going to use a linked list, and you're going to insert, suppose you're having fat and hat in the given examples, and you're going to insert gat in between them. So first what you have to do means you have to get a node from the what you call as the storage pool, and it should be there in the unused list, and you're going to name it as x. And then the next step, you're going to set the data fields. You'll be having data field and you'll be having link field. In the data field, you're going to write gat, so that data is specified there, and then you're going to set the link of x. That is for that node, you're going to place the link so that it is getting in between fat and hat. Okay, so that it is in between. The next one is you're going to give the address to the previous one, and you're going to set the address of that particular node to the next one, so that it is getting inserted in the appropriate place. Okay, the schematic diagram will be looking like this. You'll be having, first is actually the pointer, that is the starting address, and then you'll be having the data, then the pointer, then again bat, cat, eat, fat, and you're now inserted what that is the data part, the address part of fat will be having the address part of fat will be having the address of the node gat, and the address part of gat will be having the address of hat, so that this particular connection will be introduced and the original connection will be disconnected. Okay, insertion is over. Similarly, deletion is actually, it means dividing the memory into nodes, and each will be having its own link field. You're having a particular mechanism to find out which are the use nodes and which are the free nodes. You're going to find out which nodes are in use and which nodes are free. That is actually you'll be learning further in garbage collection. A mechanism to transfer nodes from the reserved pool to the free pool. Okay, this mechanism is called a storage pool mechanism. They will be having something called as a reserve pool, and you're going to call it as a something called as a free pool, and vice versa. This deals with memory. Okay, here what happens means you have to disconnect. You have to fat is actually a node. Fat will be having its own address which will be pointing to GAT. You have to change that address to the address of hat so that GAT in between will get disconnected. So this is the way. If you're going to change the address of fat to the address of hat, automatically the connection in between the node will get disconnected. Obviously it will be deleted. Okay, then we are going for three processes. The first one is how to create a linked list having two nodes. You'll be having only two nodes there. How to create a linked list which is having two nodes. First, you are going for to call get node. Get node is actually a procedure which is there in storage pool, which will be getting the node from the storage pool, that is free nodes. Okay, I is actually the node which is available and it is getting the node. This is actually a procedure. And then what you're doing here is you're going to change, that is you're going to point, that is I is, that is you're going to point it to T. Okay, and then what happens here is you're going to point it, you're going to make a pointer so that it points to T. And then next one, what happens means the data part of I, you're going to store it as mat. Mat is actually some value you're going to store. Where you're going to store, I is actually the address pointer. In that depicts the node. In that you'll be having two parts. One is data, the other one is link. In the data part of I, you're going to write mat. And then again, what happens? You're going to call another node because you're going to create two nodes. Then you're getting the second node, and then what you're doing here, in the next part, what you're doing here is you're telling that I is equal to, that is link of T. Link of T means it will be specifying the first node. Okay, you're going to connect the first node and the second node. So link of T is equal to I means the first node and the second node will be connected to each other. Okay, and then you're going to tell that link of I is the second node. The second node, or the second node address part will be 0. Okay, the first node will be there. First node will be T and the second node will be I. Okay, the address part of the second node is 0, and the data part of the second node is, you're going to write the spat. You have created two nodes and you're going to specify the last node address is 0. That's all. Okay, the other one is insert. How will you insert a particular node into the list? It inserts a node data field oat following the node pointed by x. After x, you have to point out going to insert a particular node having the data oat. So you're going to call get node of I here, and you're going to get one particular node with the address I. In the data part, you're going to write oat, which is the data, and you're going to have one conditions there. If T is equal to 0, if T is actually the original starting address of that particular linked list. I is actually which you are going to insert. So T is equal to 0. Then, okay, what you're going to do is you're going to tell that the new node should be connected to the the previous one. So you're going to tell that I is equal to T, and link of I is equal to 0. So that this becomes the last node. So suppose if you want to insert into an empty list, suppose this is actually the condition. If you want to insert into the empty list, this will be the condition. Otherwise, what you'll be giving the exchanging the link, so that what happens here, link of x is equal to link of I. So what happens means you are going to exchange the links. That means that the particular term is inserted. Okay, then delete. Delete is actually what happens means, suppose if you want to delete the first node, first the condition y is equal to 0, you're having delete of x, you're having x, y, and t. To the x is actually what is a pointer. X is actually the pointer, and you're going to delete one node, the first node you're going to delete, or you're going to delete any interior node. Suppose if you're going to delete the first node, then the condition is if y is equal to 0, then suppose then link of t is equal to t. Link of t is equal to t means that node, the first node, will get deleted, because there is no other node, the first node will get deleted. Then suppose if it is not the first node, then what you have to do means link of x is equal to link of y. Okay, link of x is equal to link of y means you're going to delete the node which is coming after. So what happens means the connection between x and y will get disconnected. So whatever, so x will get disconnected, and you're going to call return of x, which will take it back to the storage pool. Okay, then, okay, thank you for listening.